All right, let us see the basics of flame test and the wave nature of light very briefly before you do the flame test lab. You can take it as a pre-lab discussion. So one of the ways that energy travels through space by electromagnetic radiation. Radiation energy propagates through space in the form of wave. When you look at the electromagnetic radiation, you can notice that the wavelength and frequency are inversely related. You can see the frequency here increasing from right to left, and the wavelength increases from left to right. That means both are inversely proportional. Higher the wavelength, lower the frequency for radio waves. So the wavelength and frequency are inversely related, and the frequency is represented by the letter nu or f, and the unit is cycles per second. And for wavelength is represented by lambda, and the lambda is the distance between the two consecutive crests or the two consecutive trough, like here, it's shown here. See, that is called lambda, that's the wavelength. So wavelength and frequency are inversely related. When the higher the wavelength, lower the frequency. And when you multiply that, you will get a constant because they are inversely proportional. That constant is the velocity of light, which equals 3 times 10 to the power 8 meters per second. Now let us see what are electromagnetic radiation. Electromagnetic radiation is a stream of particles which we call as photons. So energy of a photon is directly proportional to the frequency. Since it is directly proportional, we can write energy of photon equal frequency times a constant. That constant is called Planck's constant, which equals 6.63 times 10 to the power negative 34 joule second. And we know frequency is nothing but velocity of light or speed of light divided by the wavelength. So h is constant, c is constant. So we can calculate energy of photon if we know the wavelength, and vice versa. If we know the energy of photon, we can calculate the wavelength. So when a photon of certain energy falls on a metal surface, it can eject the electron, which is called photoelectric effect. If the energy is not enough to kick the electron out from the metal surface, the electron will come back from the excited state to ground state, and it will give out certain color which corresponds to the frequency or the wavelength of that light. What does that mean? Let us see. So you can see that the electrons are arranged in shells, right? So when an electron is in the ground state here, say for example, and the incoming photon with certain energy falls on this atom, the electron can get excited to a higher energy level. And if the photon energy is not enough to kick that electron out, what will happen is that excited electron will come back to the ground state by releasing certain energy. So this is the basic principle of flame test. So this principle can be used to detect metal ions or a chemical compound in a laboratory. So as you can see here, the different elements gave different colors because each one got different electron configuration. You already learned how to write the electron configuration. So when you do this lab, keep in mind that this is the basic principle of flame test and also to characterize certain chemical compounds in the laboratory.